Hi everyone, this is my review of my Bigtreetech Eddy USB. I figured a few are probably curious, and I've seen a few people asking about it with regard to the USB edition. The coil edition is only out in certain regions, from what I've been told, and the USB is more widely available. So I picked up the USB edition in that regard to give it a go. Price is not too bad overall versus some of the various ones out there. I would say it's comparable. Fairly easy installation, even though it still requires the Bigtreetech fork of Klipper, or at least what it looks like to be a section of it. Just watching the installation, what it was checking out. Needless to say, I'm going to jump right in instead of wasting a lot of time to the installation process. And then some little demonstrations that I did just to show what it's capable of. And yeah, to be fair, I did go a little bit extreme, which also, showed me just how rubbish my bed is from a, looking at it point blank range. It's really not that bad, but I could do with something a little bit flatter. Anyway, so let's jump right in. So here we have the Bigtreetech Eddy GitHub. Now I'm going to show you also another one over here. This is another guide done by Crowtech. This is one I initially followed because it had been updated 4 days later. So I thought there might be one or two new things that needed to be known. Needless to say, as it says, still requires the Bigtreetech fork of Klipper, and you do need to comment, the camp adaptive meshing in that regard. This is because adaptive mesh has been put into Klipper some time ago, so you only need obviously certain aspects, but this will help even doing an adaptive mesh later. I think that as it says, instead it's been integrated. You can still use the adaptive one in your mesh calibrations and so forth. There's more information there. I'm not going to jump into that just yet. I'm just going to focus on why we're here. So coming down, this is useful dimensions of the Eddy if you're going to try and design your own mount for it. There is actually an STL of the Eddy, so if you want a physical model that you can throw into your CAD software to start modeling a mount that'll work on your particular printer, because right now the only ones I found that were on the GitHub at least was for the CNC tap, and I think maybe one or two others, but not in my particular configuration. Needless to say, jumping right in, it obviously you SSH to your host controller, whether it's a Pad 7, Raspberry Pi, Orange Pi, whatever you're running, jump on the laptop running Linux, whatever, and go into the Klipper folder, make menu config, and these are the settings that you'll choose. Obviously, I'm not going to focus on it too badly here because it's on GitHub. You can read it. Now they're telling you here how to put it in basically flash mode or DFU mode. So they're showing here that the boot button is literally right behind the USB port on this on the Eddy. It's easy enough to get a small item, maybe the tip of a toothpick or something non-conductive. Press on the button, you'll feel it, kind of click. Hold it down, obviously, and then plug the USB cable back in. You will see it come up, obviously, as Raspberry Pi RP2 boot. Follow the instructions here, obviously, to flash it. Now, I'm going to take one step point on this. Do this checkout first, then flash the device. Obviously, because when I did it in this order, obviously, coming down like here, where they have all the configurations and so forth, I ended up having to reflash it because of the checkout, because this puts your Klipper into detached head mode, means it's working with some code that is not part of the mainstream Klipper, even though it works. So do the checkout of this before you do that, and then make menu config obviously up there and make your flash for it. Instructions fairly straightforward, as I said. So obviously they have some help with the configuration. You can add some of these sections, comment out the sections that you have like this already in your existing printer config. This way you don't get duplicates. And then here's your little item. As soon as you do that first portion, you'll be and the temperature, you'll see it in Klipper. I initially have some bits obviously showing that aspect. Do your live calibration, that's obvious. Z offset, you know, in the regard to the actual setting of your Z offset. This does work, although there's still a problem with the saving of Z offset correctly. I'm not going to go into great detail, but just be aware that they have a section at the bottom that talks about this. Temperature compensation, calibration, I'll touch on this aspect because Eddy USB right now is the only version that does have temperature compensation. That's important, especially if you're probing the bed hot and the temperature is heating the sensor, obviously, which will affect its accuracy. So this is a good thing to do. Definitely follow what they're saying here in that regard. Now, as the person said, 30 to 50 C, 3 steps was sufficient. I was doing it 85, so I did it 5 steps. And there's a lot of waiting in that if your bed takes a while to heat up, you know. So because it'll prompt you for each step of this. But then it will get a proper calibration and you can go ahead and start setting up the mesh parameters. Now, I did some video, both detail and rapid, which you'll see shortly. Pick and choose on that one. Scan height, obviously 2 millimeters is what I have mine set, you know, and it works just fine. As long as you're within 4 millimeters or less is what they say right here. So has to be, should be that if the probe is more than 4, it will be invalid. So in other words, you're going to have a messed up mesh. 2 millimeters is perfect, yeah? Rapid or continuous scanning as it's seen. Here's some details on how to set it up. Now, I think they based most of this on, you know, a much smaller printer, obviously, than mine. So I had to adjust these values in that same regard. Then your start print macro to get yourself started in that regard. You take, as you can see, it highlights the adaptive one, so you can get your adaptive mesh in that regard. As far as the rest of this, this is regarding the Z offset. They are warning, you know, if you're not knowing what you're doing, don't try this. You could end up burying the nozzle. But they have an example of here how to set the Z offset that you find from the calibration into your start print config, you know, as part of your printer config in that regard. So known issues, obviously they cover it if you have a NAMI or NAMI 2. There's some detail there, and then just to adjust it. Okay, that's kind of, and they do kind of highlight the difference between the Eddy USB and the Eddy coil. The CAN bus version it is still being worked on from what I'm understanding in that regard. So anyway, the GitHub side of this, so let's go ahead and jump into the actual videos I made earlier while playing around with this. I am going to show you one quick thing though. In mine, I've got obviously the Voron stealth burner with a Voron tap, and here's my little mount, obviously showing I can still use the tap. It can still be used as a ZN stop. Yeah, if you want to go that route, obviously that is fine, but you need to make sure that Eddy stays at the same height. Do not mount it on the back portion of the tap. In fact, the adapter that I found on Bigtreetech GitHub, that is for the CNC tap from Chaotic Labs, it actually prevents the tap from doing this. It actually blocks it and stops it from moving, making it a fixed sensor. So if you try to go and use it, you're going to bury your nozzle most likely into the bed. Yeah, this makes more sense if you want to do that. I'm still working on one aspect of the configurations because I got it to do Z homing with the tap and then mesh with the Eddy. But when I told it to do Z tilt, it used Eddy. So I think there's still some messing in there to be done. I wondered why that was. It could be because of how it does that aspect, because that's part of your quad level mesh, quad bed leveling. In my case, it's dual bed leveling. But needless to say, I figured I'd show you that it is not hard to throw one of these together using the, sample model that they have, an STL of Eddy that you can use to, go into Tinkercad or Fusion or whatever to make your own mount for the Eddy sensor. There is already some out there. There is one for the Voron stealth burner. It mounts same place that a BL or CR Touch would do, which is right behind the stealth burner. Fixed location, doesn't move. Yeah. It's making me rethink, do I need to use the tap in this regard? It's nice to have it there. The stealth burner's heavy enough to keep it down and keep it from bouncing, but it is making me think, okay, should I maybe go for something lighter? Shame they still don't have the Terminator out. Yeah. Anyway, so here we go into the videos that I've made for you regarding Eddy. Okay, here's the console. Here's where I'm obviously finding the device ID, getting it ready to flash the configuration I made earlier in menu config. This is making sure Eddy is showing up on the USB. As you can see, it's set in boot mode. Here's where it's making the firmware and of course flashing it and then showing the new device ID. And this is after I've got it set up with the serial line. As you can see now, it shows as an MCU with a temperature. Okay, so here's a first run, 32 by 32 at 400 millimeters per second. I have it, as you can see, doing the normal end stop homing, and I have Eddy set to be the Z end stop. After doing a bit of testing, I figured might as well get it to do what it's supposed to. So here's my Z tilt. Obviously checking left and right hand side of the bed. As you can see, there's a bit of an offset because of where it's mounted. So this is the only thing where you're not going to get the entire bed unless you can make sure you have the room to do it. But there's my leveling of the bed, and here we go. Absolutely crazy. Duckies are spinning their little heads off. As soon as it's done, we'll check the bed to see what the mesh looks like. Here we go. This is a Troncy bed, so please be kind. Not too bad, considering. Okay, here we go in detailed mode. I know this is taking a little bit longer, but I'm going to let this run without speeding it up, just for the aspect of showing how detailed it's doing this. Now this is a 32 by 32 mesh. That means we're getting one probe point every 10 millimeters, approximately. This scan is in detailed mode. As you can see, it slows it down so it can get a more accurate scan. It is recommended for dense meshes like this that you do this method, because if you do the rapid scan, there is a high likelihood of errors. For smaller meshes, or ones that are not so dense, you can probably get away with rapid, and it'll be good enough for most prints. Especially when using the adaptive mesh, where it only meshes the portions of the bed that are just outside of your actual print of the model. This is still vastly faster than the tap for most probes. At least of the movement type, that is. An inductive might be able to do this level of scanning. Now keep in mind, these hotbeds on this particular printer are not exactly perfect. Especially when you see it at this resolution. That's rather jerky. And I obviously have one section that's way off. But if you look at the actual range here that we're talking about, okay, this is going from -2 to -0.2 to 0.2, so we're talking about 0.4 across the grid. This really isn't that bad. In fact, our highest point is 0.19 off, but it seems it's very low in a lot of other areas, even though it really isn't that bad. But at the same point, this kind of shows the detail level. Now keep in mind, this is a cold bed. Right now, obviously, the bed is not really set to a real temperature as per se. So as you can see right now, it's still cooling down from previously. It's only at 54. That's barely PLA temperatures. Since I print mostly PETG most of the time, this would obviously need doing after each print in case I change materials. So there we go. Just a little interim. I lowered the resolution of the scan to 20 by 20. That gives us 400 scan points. And it's making good time for this. I think this might be the nice medium. Although when you're using adaptive mesh, it goes by the number of points you tell it in the adaptive meshing. So it does make it more dense. So the detailed mode might be the better option, although rapid scanning will work on smaller meshes depending on the number of points. And it also depends on how fast you tell it to do it. But this is definitely making a lot faster work of that. And then we'll see what the bed looks like. Now I still have it heated to 85. Right now it's actually a little under temperature by 5°C, but you know how it is. Just send it. This is that realistic kind of testing that sometimes you can get. Throwing things at it that are not exactly expected. Okay, let's see what this has come up with. Now see, that doesn't look as bad. Now the only thing that's changed here obviously is the speed as per se, in a way, because I've given it less number of points, and it's definitely confirmed that the front of the bed is definitely a little bit higher than it needs to be, and the back is a little bit low. So sometimes we can compensate for this. That is actually closer to where it should be. Although my middle is about right. There's a little bit of a high spot right in here. Okay, so let's drop the front left corner a little tad. And obviously the rear, middle and back. So obviously we're going to raise these back up a little bit. And we're going to tell it to do it again. And there we go. Let's do that again. So go back over to our console. I haven't updated all the G codes, obviously, in this for this. That'll be once something's a little bit more finalized. Anyway, I'll come back when this one's done. Okay, that mesh is finished. This is a 20 by 20 detailed scan. Now, this is interesting because, as you can see, as it gets to the center side, this is the left-hand side, there's a dip. Yeah? This is where the 6 bed level screws would affect. This is literally high by 0.4. That's livable. Yeah. Now that says there that I've got a spot that's 0.17, yet that's just close to the side, the front middle, so I can probably pull that down a little bit. That one is just about perfect. Now I've added the flat, so let's get like this. Let's get rid of the flat. Here's our actual probed section. I'm low by 0.1, so I'm really not doing bad, but it obviously has a dip on the sides, whereas the dead center is almost perfect. Yeah? So this is a Troncy bed, keep in mind. It is very large, it's 320 by 320, so this will obviously need to be considered as far as my uses. I may need to put a support beam across the center that can help adjust the side centers in order to get this flat. But this is just one of those many things. But as you can see, I'm getting a much better picture of just how rubbish this bed is. Obviously, I know a lot of, like I said in one of the previous parts, I've had a couple people suggest maybe getting the Voron Trident bed. Obviously, I am going to look at some pricings on that. It just means I have to look at mains powering it, which I wasn't overly keen on doing just yet. But, you know, something that maybe a little thicker, a little flatter might be something here, or I can even potentially do the old trick of putting some, you know, like aluminium foil shims, obviously, in between the PEI sheet and ultimately the, you know, the bed magnet. That should obviously help with those little low points, because they're not that far low. But yes, this is the level of detail that you can get when you can probe this amount of spots in a reasonable period of time. Now I'm going to do another one now at a rapid scan. Now I'm going to show this one. This is our rapid scan at 200 millimeters per second. So here we go. Ready? Go. Millimeters per second. Yes, obviously this time I heated the nozzle to 240. It's still heating, but bed is already at 85 at this point. Okay, good result. As you can see, still reasonable period of time. Let's go over here to the height map. Still reasonably consistent with the previous. still showing about the same dips. So let's go ahead and drop that front just a little bit. .0 something, I'm not going to worry about that. Nope. It's just that center point. So let's try it again. I really need to update these scripts. And here we go. Nice fast 200mm/second scan, 20 by 20. Two more rows. Okay, 3 more rows. There we go. Yep, we've just about got it there. Now see, that's a bed mesh I could live with. 0.04. That's still a little on the high, but I'm really not going to worry about that. But these two sides, that's going to have to be a mechanical change to compensate that bed. But there we go. There's Eddy doing several meshes as high as 32 by 32 at 400mm/second. Seems to me the most reasonable thing to do here is 200mm/second. You can guarantee a little bit better accuracy. If you want to do a crazy mesh like this, it'll really give you a better understanding of your bed. Don't let it obsess you, okay? If you look here, the scale is minus 0.2 to 0.3, okay? The bed level system is capable, both on Klipper and even Marlin, of up to 2mm, okay, of change. So this would have to be, you know, 1.0 to minus 1.0 in order for you to have to start worrying. This is actually considered a good mesh. You are also going to want to go into your configuration, because you don't want this mesh being applied to your entire model, especially if the top's supposed to be flat. Yeah. So if you go down into your printer config, obviously get into, this is all my configs, obviously. Here we go. This particular section right here, okay, fade start, fade end, target, okay, so you're going to start at the first level applying the mesh. Stop applying the mesh after the 10th layer, because otherwise that mesh, if you have a very wonky bed, it's going to apply that to your entire print. And if it's something that needs to be dimensionally accurate as possible, you know, either get an extremely flat bed, that's going to cost you a penny, or drop the fade. Let it obviously get back to normal by the time it gets to the top of the print. So there you go. There's my little so forth review of the USB Eddy bed level sensor from Bigtreetech. I'm really impressed with it. I've had my reservations on this type of sensor. As I said, I have a Voron tap. The zero offset for the nozzle obviously is quite appealing. This, where it's currently mounted, has about 45mm to the right, so it's not exactly getting the entire bed like the tap would do, or clicky, but you know, obviously I'm seeing that I probably don't need the tap, so there is an adapter obviously for the Voron stealth burner that you can mount Eddy directly behind, obviously the stealth burner, obviously where you would normally put, such as a BL Touch or CR Touch or any of those. So I may go ahead and consider doing that. And there we go.